Hello, good afternoon, everyone who all are joining in and who may join later in the event. This is your host, Himanshi Kaushik, and I heartily welcome you in today's session/webinar on navigating the data science landscape, career insights, and opportunities. And I hope that you all are doing fine, happy, sound, and healthy at wherever you're taking this webinar from. So before we move on and learn a lot more about the data science today through our session here, we have our expert. So I shall introduce you to our expert. We have Ms. Shuchita Jain, a client development and marketing Transorg Analytics, a data strategist and management consultant for startups, scale-ups, and corporates in driving revenues and growth. She has over 16 years of global experience in providing advisory to and working with client side customers, HODs, functional and departmental heads, and other key stakeholders and leadership teams at large corporates and tier one companies across industries and geographies. So, ma'am, this is again a pleasure for us to be here in the webinar, to be able to listen you and to learn a lot more from you and from the company, of course. And with this, I would also want to welcome our second expert, Ms. Anju Jain, ma'am. I again sincerely welcome you in the webinar. And now I would like request Suchita ma'am to kindly take over the screen, and over to you, ma'am.
Thank you, Himanshi, and thank you once again for inviting me back. It's always a pleasure to interact with the students at LPU, and through this interaction, we hope that we are able to convert many skeptics and people sitting on the fence to convert into a career of data science. This industry is fast moving and evolving, and every day there is something new to learn. So for people who are highly curious, who have a good command on technology, or even if they're curious, at the end of the day about new things and they want to constantly learn, this is a career which is the right career for everyone. So thanks for the introduction. So I'll skip through my introductory slide. I'm approachable on LinkedIn as well. So if people are curious to know more about what Transorg in particular does, we do some really interesting work. Transorg has been in the industry for close to 14 plus years, and I've been fortunate enough to be part of it since its early startup days. And like you said, we specialize in customer marketing, supply chain operations, risk analytics use cases for large corporates and tier one clients. And there's a lot of interesting work we do for banking, insurance, telecom, aviation, hospitality, CPG, retail, across verticals, so something new to learn. People can visit our website to learn more. So coming back to the agenda, for some of the people who are new to the world of data science, what we brought together is a basic presentation, which will cover some key insights on what exactly we mean by data science, machine learning, AI. These are some buzzwords which are floating around a lot. Then what are some of the problems which the data scientist community are solving in today's world? Some top trends of the industry, the kind of jobs you can expect once you graduate from the program, which LPU is co-launching along with Transorg, and why you should personally pick a career in data science. And eventually we'll give you some tips on how you can further a career and build a long-term career in this field. So before we do that, I always like to play this video because it gives you a small perspective on where the industry is moving. So right from basic data analytics to now generative AI and cognitive AI, conversational AI, there are lots of I would say tentacles and offshoots of the AI world as well. So it's interesting for students to know more about it. So have a look at this video is what I will suggest.
Superintelligence that far exceeds any human. I think it's very obvious. So they'll play this move, which I want to hear more about in a second, but Lee has left the room. He left the room after that. So wait.
Everything we have is a result of our intelligence. It's not the result of our big scary teeth or our large claws or our enormous muscles, because we're actually relatively intelligent. And among my generation, we're all having what we call holy cow or holy something else moment, because we see that technology is accelerating faster than we expected.
Bots targeted millions of Twitter and Facebook posts carrying links to stories on conservative internet sites such as Breitbart and InfoWars. AI might take a little while to wrap its tentacles around a new skin, but when it does, when it gets it, it is unstoppable.
Yeah. So I don't know, because of bandwidth issues, sometimes students may be unable to view the video, but very quickly, the key takeaways from this video, and it's a little bit of a dated video, but still I like to present it because it gives you a holistic view of where all your impact as a data scientist you can give in the world, right from healthcare to self-driving cars, to robotics, to gaming industry, entertainment industry. There's a lot of work which data scientists are doing to actually solve business problems. And when I say business problems, it could be to do with, let's say, customer management. It could be to do with better marketing spends, improving the spend of the company without, impacting the company's overall profits or revenues. It could be in improving the supply chain logistics. So there are wide use cases, wide areas of business where data science can be applied effectively. So what's important as a data scientist is to know the fundamentals, because the world is evolving. 5 years back, we were heavily working in using predictive modeling, machine learning. Now the industry is more changing towards generative AI and using large language models for problem solving. So it's a fast-paced changing world, but as a data scientist, you can keep pace with it by, always investing in your learning. But fundamentally, what exactly is data science? The first you have to understand, it's an amalgamation of multiple skills. Some of us may possess it, from our school days, naturally curious about fields like mathematics, statistics. Some of us, may not have come with that orientation. We may not have studied, science and all in the undergrads. However, there is a natural curiosity to pick up this field, right? So what is most important is to understand the building blocks in data science world. And to begin with, the very first thing I always tell people who want to join this industry is to understand what exactly the key skills are required. So the very first thing you need to be very good at is having some understanding of the statistical modeling concepts and basic mathematics, that you are able to, from algebra and all, you are able to understand how to create equations, how to solve for equations. So these are two very fundamental skills that you can easily brush up and pick up. And some of the courses, including the LPU course, will easily be covering this. The second most important area you have to understand is the technology, the underlying technology which is being used by data scientists. So even, let's say, 4-5 years back, we were heavily using platforms like R. Now we've moved on to Python. So technology and tools are constantly changing. Earlier, clients or our clients, for example, would be working on-premise servers. When I mean on-premise, these are large data servers, large data warehouses that they had built in their own environment. Now, with the availability of cloud-based computing, clients don't have to invest in a large data infrastructure, and they heavily rely on cloud service providers like AWS, Azure, GCP. So a basic understanding and orientation to cloud-based technologies and versus on-prem. What are the top platforms, for example, from a coding point of view, from data presentation, visualization point of view. These are a must understanding for you to be successful in the real practical world. Fourth basic skill that I feel that you should definitely possess is a naturally curious bent of mind. So understanding how scientific methods are being implemented. Machine learning models have a certain flow, a workflow. So you need to understand right from the fundamental steps of data understanding and consolidating your data to cleaning it, creating additional features, which is typically called as, feature engineering, to working with different algorithms and deriving the best performing model, and then eventually using ML ops techniques to eventually productionize those models in real world. So the entire workflow should be well understood by the data scientists, so that once you start working, your models are actually seeing the light of the day and they're not like theoretical concepts alone. So business adoption is very important for machine learning and AI to take the next step forward. So that is again a curious mind, and applying that. Another skill set to acquire is to be able to explain what you are doing, and that comes with good data visualization techniques. And this is something which very sometimes data scientists cannot convey very well. So you have to be a very good storyteller, because a lot of the business community will not have data science orientation. They will not be speaking your language. So you have to be the conduit between the business side of the world and the technical side of the world. And you should be able to convey your model's interpretation, your model's finding, or even your basic data analytics findings in very compelling and easy to interpret visualizations. And today there are a lot of off-the-shelf products that assist data scientists, products like Power BI, Tableau, and all. So you can pick up those skills as you move along. Lastly, I feel, and this is something which is very important, and this is how you'll differentiate yourself in the long run. Technology will always outpace the world, right? So you will always have to do a catch-up game with that. But how you can differentiate yourself from other data scientists is the domain knowledge that you carry. So you have to understand the business world. You have to understand, for example, if you build your career in banking or you build your career in insurance, you need to know the fundamentals of that industry. How does that work? How does that industry get regulated? How do changes in regulations impact the industry use cases? How the customer behavior in your industry is changing vis-a-vis other industries? Within your customer bases, what are the different kinds of customer segments and how are they different from each other? What you can do to improve customer engagement, for example, to drive revenue. So building the domain knowledge takes time. Experience is the best form of teacher here, but there are other ways in which you can catch up with the industry, and I'll talk a little bit about it later towards the presentation. So quickly moving to the next part of the presentation, I thought to bring this in for you for a quick understanding on why this field has been growing for so long. Now, the reason why it has been growing is because there's an explosion in the data availability and growth in the data. So of course, in the late 1950s, early 60s, 70s, IBM launched some of these large scale servers. It used to take tremendous amount of computing power to even process kilobytes of data, and a lot of the business data was in flat files, or it could be even in paper forms. Going back 20-30 years also, in India, a lot of the businesses were being driven on paper based, so a lot of the data was not getting captured. But now with availability of cheap storage and computing power, it has become possible for businesses to digitize and capture a lot of the data points. So a lot of, for example, the customer interaction points, which could be lost. When you walk into an Airtel store, for example, you check in, you give your information, they are able to track that, okay, a customer walked in at 11 a.m., he stayed back, his problem was solved. So a lot of the offline interactions are also slowly getting captured digitally, and that data can be processed very effectively to cull out insights from that. So there's been a tremendous amount of growth in data, which has led to the adoption of data analytics. And as you can see, the computational power has also increased tremendously. So it has become easier and easier to process large amounts of data. And that has also become one of the key reasons why data science has been fast evolving. So both with the growth in data itself, as well as the pace and growth in computational power and storage power, it has been possible for the data science community to be able to crunch large amounts of data for problem solving. Now, this is a quick look at the adoption or the growth in the data science community in itself. So in the early 50s, 60s, and 70s, like I said, there would be a small group of statisticians sitting somewhere in the back rooms of large offices, and they'd be working on some basic models. And there will not be a lot of gestation. They'll be sitting on those models for years and years and building some models. And there would hardly be any business user who would be aware of those teams sometimes. So there's been evolution in the use of data science from basic statistical data analytics to data mining, to building some business intelligence reports. Businesses started to report, okay, what has happened, how has business performed, what lines of businesses are growing, what product categories. So there has been a lot of reporting about business as usual. Then the world came to more advanced big data analytics. In today's world, we do a lot of predictive analysis, a lot of scenario building, simulations, forecasting. So we are using historical data and treating data, for example, with outlier data for during the COVID years, and then building forecasts and scenarios for businesses to take forward in the future. So there's a lot of maturity in the way data science use cases have evolved as well. So this is a quick look at some of the key trends that the industry is experiencing. So like I said earlier, client accounts, large businesses would invest millions of dollars on buying, setting up, and managing their own data servers. Now, whenever they are setting up data servers, they would be physical as well as digital limitation to capturing and processing data. And for example, even if they are able to store their data, it would be tremendous amount of cost, computing power, which would be needed to analyze data for years and years in the back end. However, with the adoption of public cloud, it has become easier to store your data. It has become easier to create your data warehouses and data lakes on the cloud, so that you can process even 5 or 10 or 20 years data easily without investing millions of dollars on setting up and managing an infrastructure. So there's been a big adoption of cloud in the industry, and this is something which is really relevant for you to pick up. There are certifications available from LPU, from Transorg, that will help you to get the concepts in cloud cleared. The second most important trend that the industry is seeing is that data has become more actionable. So rather than being recorded for record keeping, for auditing purposes, nowadays businesses are using data for actually solving a business problem. So a quick example for that I can tell you is that whenever you're interacting with your bank for whatever reasons, whether it is for your saving account, whether it is for your car loan, home loan, for your investment or third-party products like insurance, all of that data is being recorded. Earlier, it would just be recorded and the bank would not really do anything about it. But nowadays, you would see that you are getting very personal emails. You're getting emails, for example, that your auto loan is about to get over. Would you like a top-up loan on your car? So how does the bank know that, that particular data piece that they had about you, they are using it for cross-selling additional products to you. So the data has become more actionable from that point of view. Another key differentiator which is coming in the industry is that nowadays there are third parties that are selling a lot of data that they are collecting from the industry in general. An example of this could be Nielsen, which is a market research and advisory company, and they collect a lot of third-party data. For example, for consumer products companies. Consumer product companies are those which are creating and selling products in personal care, home care, food, beverage. Now, typically, these companies sell to distributors who sell to retailers, and retailers are the ones from whom you and I as a consumer buy. So the company that has produced would not have visibility of who the consumer is. However, nowadays, these companies are able to build consumer insight models because they are purchasing these third-party data points and analyzing that to better understand that besides the retailer level sales or the distributor level sales, what are the trends in the actual consumer spends and actual consumers consuming the products within my product categories or with my competition. So they get a lot of third-party data, which they're integrating with their internal data for additional insights on the consumer adoption. So these are new trends which are coming up. Again, we've talked a lot about analysis of massive amount of data. One key trend which has come out is that besides consumer-facing businesses that were quick in adopting data science and analytics, there are other industries like manufacturing, core manufacturing, heavy machinery, or equipment management companies that have started to use data science. And how that has been made possible is through an amalgamation of hardware plus software integration. So there are now edge computing hardware which are available that will be able to monitor through real time what has been the performance of a machine, what is the temperature, vibration, sound level, performance or pinging of the machine, so that they are able to predict if a particular machine in a factory floor, there is a requirement for, let's say, repairs or services, or if a machine is going to fail. So this in itself is a large application of data science and fast evolving. And again, this is an interesting journey. We mostly work in consumer space, but the industry is also, other industries are also using data science for problem solving. Another new area that you can look at, and if you're naturally curious, is how conversational AI is evolving. And the fundamental block for that is natural language processing. The way you and I are talking today, for example, machines are now able to interpret our speech. They are able to convert it into text, and then the text is being used for analytics purposes. This has been made possible again through large language models. If you're naturally curious about it, then go through some of these open source products like ChatGPT, DALI, which have come out from OpenAI. You can register through your own personal email and play around with the platform and see how the platform is able to have a conversation with you. Another application of this is, for example, if you have Alexa at home, or Google Home, you would see that when you are talking to the machine, it's prompting you, it's able to have a clear conversation with you. For example, if you are curious about weather or traffic, or you just want to listen to a joke or a piece of music. So this conversation that you are having, which is not a peer-to-peer interaction, but a human to machine, that has been made possible through the techniques of NLP. Again, a very interesting, fast-paced growing world of part of the data science world. And I'm sure that some of you will pick up interest in that. At the end of the day, what data science and machine learning and all of these various tools and techniques are doing is that they are enabling business houses to be able to use their own internal data and their external data effectively for their own business problem solving. So earlier, a small or a narrow group of people would be able to use data science services, but now we see that even human resource teams are using. For example, AI and machine learning are being used to analyze the resumes which are coming for applications. If you look up on LinkedIn for some of the very large popular companies, you will see for some of the open positions, hundreds of applicants are applying for with their resumes. It's not possible for an HR manager to go through every resume fast. And so you have application tracking systems, you have application interpretation systems. These are able to quickly look out for the buzzwords and are able to segregate relevant applicants from the non-relevant applicants. They are using NLP, for example, to identify the right skilled persons with right experience as well. If there is an experience gap or the education is not from the premier institute that the client is looking for. So there's a lot of application which is happening even in human resource. Similarly, HR teams, for example, are now tracking which employee has a likelihood of attrition, or basically they might leave the company in the next few months. And they are tracking the employee behavior, the employee's engagement, the employee's performance to be able to predict whether or not that employee will leave. Similarly, customer management teams are able to figure out the same problem, whether or not a customer, existing customer, loyal customer, for whatever reasons, whether service or product or dissatisfaction or a better price from competition, is about to leave. So all these use cases require data science interpretation, and that's where the data science world is evolving. Now, this as an example, I thought I'll pick up a few case studies just to let you know how in the real world data science is being used. So all of us love, I'm sure, to listen to music, right? Now, whenever you go and register yourself on platforms like Spotify or Apple or any other third-party websites, what's important is that they play the music that you like. So for example, if you like Indian classical or Western classical or hard rock, metal rock, the more you listen, the more you search and start listening to the music, the more the platform's algorithms learn about your preference, your behavior, and the platform can figure out that people who like rock music will also like metal music. And then the platform will make those kind of recommendations to you. And that's how you end up getting more and more engaged with that platform. Similarly, if you look at e-commerce, most of us are, I'm pretty sure all of you have at some stage or the other went and made some kind of purchase on some app, whether it be Amazon or Flipkart or Myntra or wherever. Now, what's important again for the platforms to understand is, first of all, they should be able to uniquely identify you, which they are able to do. If you are a registered user, they are able to track you through your email ID, phone numbers that you are using for registering and logging in. Once you have logged in, then the entire browsing history, what page you have opened first, where you have dwelled more, wherever you have clicked more. If you have liked a product, did you scroll through the whole page or only part of the page? Did you go through the demo video? Did you add it to the cart? Did you look for a coupon? Did you actually use a coupon? At the time of making the payment, did you then, close the app? So all of that data is being analyzed. Your historical purchases are being analyzed. So for example, if you have a baby at home and you're buying a lot of baby care products, the platform will know that, okay, this person is requiring some baby care products. So the platform will make some similar recommendations to you. So all of these are coming from the use of data science and machine learning areas. In the interest of time, I'll skip through some of the other examples, but you can always look up if you're curious about healthcare, how healthcare is using analytics, or how social media platforms are using analytics. Look it up and you will see lots of interesting stories of how, analytics is being used there. Now, one thing I wanted to give you a quick overview was, what are the different stages or application areas of analytics? So at the very start of company starting the journey in adopting advanced analytics, the base level of the company is always about consolidating their data, bringing all of their data possible into one particular platform. Because whenever you're running a company, you end up buying multiple types of software for different needs. HR team may need a certain software, operations team may need, manufacturing team will have a different, marketing, sales may have a different software. Now, all of the softwares are capturing and generating data. Those data sets may not be able to speak to each other directly. So as a data scientist, the first thing you have to do working with your data engineer is to bring all of that data together in a centralized data warehouse or a data lake. Once that data has been brought in, then based upon the business requirement is when you start working on different use cases. So at the very start of it is when businesses are doing some kind of basic reporting. For example, the sales heads wants to know how much sale has happened in the last week, in the last quarter, in the last month, in the last 1 year, across what product categories, how much we have sold by value, by volume, which products have sold more, which products have gone on marked on pricing and discount pricing at full price, which customer segments have bought more. So sales guys would need certain kind of business reporting. Similarly, other teams like marketing may need different kind of reporting. So the first thing what you are doing is reporting on what has already happened, which is called descriptive analytics. The second use case where heavy usage of analytics is happening is diagnostic, or why did it happen? Here, you're looking for exception or outlier or errors. For example, if something bad has happened, let's say in the last quarter, you are seeing a huge dropout from your new customers. People are signing up on your platform, but then they are not, transacting at all. They are deregistering. Now, this is something which is an outlier, and you want to better analyze what has happened. The root cause could be either they are lost once they have come on the homepage is so cluttered, they don't know where to go, or they're not finding the information that they were looking for. So you do some kind of a root cause analysis to figure out what has happened. This can also work even for good situations. If a campaign has done really well, you want to still understand what has gone good with that campaign. So this is where you apply diagnostic techniques. Once the businesses have got a very good grasp on descriptive and diagnostic analytics is when they start moving towards future scenario building and forecasting and predicting what will happen next. And why this is necessary is because decision makers can make better plans. They can optimize the resources. Businesses are always short on resources, both on time, money, and employees as well. So you want to make good use of your time. You can plan in ahead, you can take proactive steps, and you can maintain your competitive edge. And that's why predictive analytics is heavily in use. Now, what do we mean by predictive analytics? For example, I've talked about customer attrition. So if I know that I have 100, if I have a small group of 100 customers, I can still do, personal calling, keep in touch with them. There is a frequency by which I can interact with them. Now, scaling it up to 100 million customers, that may not be possible, that I have an army of millions of sales heads who are constantly talking to 100, 200 customers. So that's where predictive analytics comes into play. Just by analyzing the transactional data, the behavioral data, the demographic data about your customers, without even interacting with them in some instances, you are able to predict whether or not the customer will leave. And this is where the beauty of data science comes into play. So these are some of the very heavy use cases for data science. Another area that you can look at is forecasting. How much can I plan? How much should I be producing? How much should I be selling? How much can I sell? How much what the market demand would be? So forecasting is again a future scenario that we're doing. Another area where data science is being used heavily is in prescriptive analytics, which is where we make recommendations. So like I talked about e-commerce platforms, it's very important for them to know what to do next with the customer. So if you have bought a baby care product once, it does not necessarily mean that you need baby care products for the next 6 months. For all you know, it could be a gift that you bought for someone you know. So the data scientists would be able to decipher that, okay, Shuchita, for example, usually buys electronics, but this time around she's bought a baby care product. Perhaps it may have been a gift for someone, right? So these trends would help the business understand that, okay, instead of making a recommendation for baby care only, let us still give her a recommendation. Let us still give her an offer in apparel and electronics, which are a preferred category. So prescriptive analytics solutions help you to decide what action you should be doing. Again, AI, I've talked already very quickly. There are multiple applications of AI now. Conversational AI, I've told you once. Even generative AI is part of the conversational AI world. So again, these are advanced use cases of analytics, and you would love to solve some of these problems. For example, self-driving car. How can the car determine the objects, the space on the road, how much space to keep with the car in front of it, behind it? All of that, comes from advanced analytics applications. I'll take the questions towards the end if it's okay. And I'm just doing a quick time check as well, because sometimes I speak a lot. So again, we have talked a bit about some of the use cases. I'll skip through human resource, sales and marketing. I've talked about it. Operations I've talked about. So quickly, if you want to take a screen grab, just do that. These are some quick use cases that we thought we'd bring to you. Businesses, for example, if I talk about sales and marketing, how can businesses in today's world make their customers loyal? You have millions of customers, right? They are interacting with you at different stages of their life. Some customers prefer digital interaction. Some customers prefer offline interaction. So businesses launch, for example, new strategies to hone in and maintain the customer base. They could be bringing in some loyalty programs. They could be bringing some reward programs. They could be personalizing the offers to you as per your preference. So think, I always give an example that, if you like eating pizza, now whenever you buy a pizza, you are very clear that you prefer certain toppings, right? Now, if the company wants to grow your business more and they want to do more, based upon the people like you who have bought the same kind of product, the company may make some cross-sell, some upsell offer to you that, okay, along with the pizza, if you buy an appetizer, you get 100 rupees off. So they're inducing you to take that action so that you are sticking to the company, you don't go to a competition, you end up spending more, and you keep returning to them. So your frequency is improved. So these are some quick use cases where tremendous amount of data science and analytics is going. Excuse me. So again, this is a quick example from the banking world. Very quickly, when you're starting your journey with a bank, for example, let's say you want to take an auto loan, you want to buy a car. So the bank has to decide whether you will be a good customer in the future or not, based upon the application that you submit. So the bank is doing some kind of a risk underwriting for you. They're analyzing your attributes. They're analyzing your financial health, the kind of loans you've already taken in the past, how your repayment behavior has been. They use that They use third-party data like credit bureaus, CIBIL, for example, to analyze the risk health of that person. And then eventually they will either approve the loan application or they will reject it. Now, once you have been approved and you become a customer, then they start analyzing your repayment behavior, how regularly you are paying, are you paying on time or not? Are you looking for any extension for your loan? Then basis that the customer getting personal offers like cross-sell, upsell and all. Now, one level of analysis is happening at a customer level. Another level of analysis the business has to do as a group or a portfolio level. So for example, whether retail individuals or small or medium businesses or corporates, how the portfolio health is, how the portfolio is growing, is it profitable, is it not profitable? So there's a lot of analytics which goes into that. Now, during COVID years, unfortunately, a lot of people lost their incomes, lost their jobs. For example, they were unable to pay. So businesses, banks had to analyze what is the risk of this customer not to repay his loan, for example. So we would be looking at customer default models. And basis that, we would be informing the in-house collections team which particular customer to prioritize for collections, right? So these are quick use cases that, I thought that as a consumer of banking services, you would be able to relate to. Now, again, some quick insights, like the kind of jobs that are open, like millions of jobs across the world are open. And it's been almost around 30 to 40% hike for some of the very compelling, profiles in the industry. People are able to take hikes of 30 to 40% as well. A quick look some of the roles. This could be curiosity for some, what type of roles there are. So this data, and each role comes with its own strength. I would not say that one role is superior than the other. So for example, a data analyst, the day-to-day job for this person is to help collect in data, interpret the data, do a lot of diagnostic or descriptive analytics, build beautiful dashboards for business teams. So they do a little bit of machine learning and analytics, but they are heavy more on data interpretation and data analytics. Now, data engineers, this is again a key role and a very critical role. So while they are not sitting and actually analyzing the data, but they are making the data available. So like I talked about it, businesses may have invested in multiple types of software and they need to integrate all of that data. They need to clean it, bring it together so that the data scientist can work on that. So that's the key role of the data engineer. He builds the data pipelines from legacy softwares into the data staging or the data storage layers, which could be either on cloud or on-prem. So this is again a very critical role and the very much in demand in the industry today. Now, machine learning engineers, again, there'll be interpretations of this job role, but in essence, these guys are heavily using machine learning for business problem solving. They are developing deep learning, ML, learning models and testing them in different environments, then productionizing them. They also help the data scientists. Data scientists may be working on complex data analytics problems, but these folks would be working primarily on ML applications. And last but not the least, data scientists. The way these guys can differentiate themselves from the data analyst, ML engineer, or data engineer is that besides they are ultimately problem solvers. So they will have a very good understanding of the business fundamentals. They would be very good in statistical data modeling and foundational knowledge of data science. And eventually these guys are supporting the business function. So you would typically get mapped to business teams while you are centrally working in the data science team, but you are typically mapped with the business team. You'll be working for the marketing heads or the supply chain head or the sales heads. So you will have a good understanding of business. You will be able to do data. You will be able to do the job of a data analyst plus a machine learning engineer as well. So again, these are interrelated, interdisciplinary roles. There are finer differences. You can learn more about it online when you research jobs. But again, these are specializations that you can pick up once you enter the world of data science, right? So a quick look again at this is something which is always of interest, and of course this number can always be updated with the latest, but depending on the career path that you choose, these are some of the average salary packages that we have seen in the market. Not to say that outliers or really superior performing people will also get locked into these rates, but typically what we've seen is even for freshers, there's a huge jump right now in the data engineering bracket. You can look at starting packages of around 7 to 10 lakh rupees per annum. In data science, we've seen around 5 to 9, and analytics profile 3 to 7. Again, like I said, they are interrelated streams. They complement each other while you have your own unique skills, but you are very much needed in the world today. We need analysts who can do beautiful data visualizations, can support business guys. We need data engineers who can synchronize and bring together all of the data. And we need data scientists who can build these predictive models and apply machine learning for problem solving. So all the roles are critical in the business today. I don't see any role becoming obsolete anytime more. Depending upon your own personal comfort, your capability, aptitude, you can choose a path of growth for yourself. And towards the end of this presentation, I'll also quickly tell you a little bit about the program that we have launched with LPU. I'll skip through this slide in the interest of time because we do want you to know a bit about the program. So these again are some use cases on what businesses are focusing on now after post-pandemic. There's been a revival in improving sales, in reducing supply chain disruptions, in cost optimization. You would have seen in the news that there are certain markets like US and all that are experiencing some recessionary environment. There has been some large scale downsizing of companies. Cost optimization has become a key focus area, especially in the world of tech and social media. So these are some use cases which the business is working on, and this is where data science is helping them. So how can you build a career in data science? Now, we've learned a lot about what data science and how they do. First thing first is to identify the right data science courses, and LPU has brought together a very compelling program, which I'll talk about it right away. So this is something for you to consider. Secondly, that I always tell people is whatever industry you're naturally curious about, whether it is banking, insurance, airline, learn more about the domain, learn more about that industry, how it is working, how it is, using data science. So for example, aviation, how commercial airlines are operating in India, what are their key challenges? Like the biggest challenge for them is the cost that they invest. The biggest cost head for them is fuel, because government tax is almost 50 to 60% on the aviation turbine fuel. After that, the next biggest cost, of course, is people. The third big cost head, which is actually the airplanes, they have been able to lease them and buy back, and they've been able to reduce that cost. So how are they using analytics? So learn more about the industry so you can, better work in that industry. Third area is to always identify some kind of a mentor, some senior in the industry who can help you to monitor your progression in the company. They can help you to pick the right courses for yourself. And if you're stuck somewhere in your career, how you can improve and enhance your career. So to talk to people and seek out mentors from the industry. Last and most important for you is because you are freshers, industry, there is a dichotomy in the industry. The industry wants 18 years of experience, and you may be 18-year-old yourself. So the way you can differentiate yourself from the others is that go for case studies, go for competitions, go for internships, whether it is paid or unpaid. The idea is to build your resume. Give me a second. The idea is to build your real world understanding, to build your resume, to show that you understand the business problems, you have a good grasp on the technology, and for that you need to practice. And so work on internships, work on competitions. LPU's program covers that. Excuse me. So now very quickly, I'll take you through the course program. Sorry for that, my throat is getting itchy for some reason. Okay, so Transong has partnered with LPU to bring together a BTech honors degree for you, which is in computer science and engineering with a specialization in data science and data engineering. I'm hoping that everybody is able to see it clearly. Now, this is a 4-year full-time degree program, which is going to help you specialize in data science and data engineering domain. we have already seen in the presentation earlier, there are certain areas in the world of data science, that is data engineering, visualization, excuse me, big data analytics, machine learning. All of these topics would be covered in depth in this program. And this is a mix of classroom work, practical field work, live industry projects. You'll have internships which are being offered, mentorship as well. And eventually, this will help you to become a quant technologist, something which includes both quantitative analytics, mathematical skills, and computer skills, right? So what is the kind of roles that you can look for after you have completed this degree? You can look at becoming a data analyst, a data scientist, a data engineer, a business analyst, a risk analyst. Of course, there are finer differences between each. In the interest of time, we'll not be able to cover. But if you go to LinkedIn now and you look up these terminologies, look up for jobs, you will see thousands of jobs are available in today's world. For example, in India, if you are flexible for relocation, there are hundreds of companies in cities like Hyderabad and Bangalore that are basically large MNCs, large corporates, their back offices, which are typically called GCCs, global captive centers, and they are scaling up hiring of hundreds and thousands of data scientists at scale. So these are good opportunities for you to grab onto to build your career and get into a fast growing and fast and large high paying roles. Some of the areas again that we are specializing on in this particular degree will be, of course, basics like statistics and probability theory, data science on Python, design thinking, data exploration, data visualization, descriptive analytics, machine learning. You'll also go through some concepts of deep learning, predictive analytics projects. So it's a comprehensive program that will help you to open career tracks across any one of these roles. And some of the other unique achievements about this particular course is that, we have industry partners that will help you to work on live use cases, on live business problems, and you will not be working on very old data sets or working on data set which does not reflect the real world. So you'll actually be looking at real world case studies and interpretation of real world data. You will have an opportunity to participate in different kinds of hackathons, datathons, workshops, guest lectures, which will also enhance your theoretical knowledge as well as practical experience besides the internships that we've talked about. We also have mentorship sessions lined up for you. So if you are looking for, like I told you, if you're looking for guidance from specific industry experts, data scientists who've worked for 5, 7, 10 years in the industry, you'll be getting the chance to get mapped to a mentor. And of course, upon successful completion of the program, you will be going through the placement rounds and get an opportunity to be interviewed by some of the best companies. You've seen some companies here as an example that are visiting LPU on campus. So you get an opportunity to be able to directly interface with the companies. And lastly, but not the least, it's important to, like I said at the start, it's very important to understand the latest tech tools and technologies in place. So for that, the program comprehensively covers right from your coding environment to data engineering to visualization. So you will get a good grounding in Python and Tableau, Power BI, in Excel, SQL, and Google Analytics. So you will be well placed. You don't have to independently go for certifications for all of these. And this program will pay off from this point of view. So very quickly, I thought to share some insights on the program. Himanshi, happy to take some questions at this stage.
Yeah, hi. Okay, just
Yeah.
Yes. Okay, so thank you, ma'am. First of all, thank you for the presentation. And I've seen, I mean, there are multiple questions, and I've seen ma'am, Anju ma'am has answered some of them.
Yes.
So, yeah, so ma'am, this one question is, again, it is from anonymous attendee. It says, how do data scientists collaborate with other professionals such as engineers, business analysts, and decision makers within an organization?
Yeah, right. That's a great question and a very practical sounded question. So see, these are typically interdisciplinary teams. Like I said, as a data, so it depends on the kind of organization you end up joining. very quickly, if you join the client side of companies, when I say client side, these are companies which are using analytics for their own business problem solving. For example, you join a bank or an insurance company or a telecom company. There, typically, data scientists are working in turn as in-house experts, and you work together with the business head. So typically, your bosses would align you to a large functional team. Like I said, it could be either a sales team or a marketing team or HR team, whichever has a large adoption of analytics requirements. You could be either be mapped to that particular team and you're exclusively solving the problems for that team. This is typically the model for large corporates. For example, if you look at a very large consumer bank like ICICI Bank, they may have someone who's working in the risk analyst profile. Now, as a risk analyst, you are typically working with the chief risk officer's team. You're helping him to understand the credit worthiness and the risk profile of either the existing customers or incoming new customers. So typically you're aligned to the business teams. In other instances, in other client organizations, we have seen that the data scientists work across multiple teams. So depending on the size of the company, you may be supporting the sales team, the marketing team, the HR team as well. Now, how are these teams formulated? Like you rightly asked, depending upon the individual's skill sets, the bandwidth and capability as well. You could be working together with a data visualization person to help create beautiful dashboards on these platforms like Tableau, Power BI. You could be working with a data engineer to bring the data to a central data warehouse. So it's a collaborative team. It's a multidisciplinary collaborative team that you will be working. We have also seen situations where one-man armies are there, where the person ends up taking multiple roles. So these are interrelated and finer roles depending on the end company that you join. You may be working as part of a large team or sometimes as an individual contributor as well, right?
Yeah,
Okay.
thank you, ma'am. Okay, ma'am, we have other query. Okay, so I think you were mentioning something about forecasting, right? During the session. So Priyanshu just wants to ask, forecasting means what? I mean, forecasting based on past data or what?
Yes, forecasting is typically built on past data only, Manshu. So let me give a quick example for that. I talked a bit about consumer product companies, right? So these are companies which do not have, like, for example, if you are buying coconut oil from the market for your personal consumption, you are typically not buying it from the manufacturer himself. You are buying it from, let's say, a kirana store or a big hypermarket or a supermarket someplace, right? Now, for the coconut oil manufacturing company to decide how much to produce will be based upon the trends that it sees in its sales. Which geographies are performing better, which states, for example, North Zone, South Zone, Rajasthan, Delhi belt, they go down to the locality level, for example, Horse Khas or Greater Kailash. They are able to analyze this data at that level. They're able to understand how the sales is happening, and they can use the data science algorithms to build a forecast for the future. So excuse me. Right. So Himanshu, just to quickly address it for you, we are using historical data and we are building the forecast based upon the historical data only. But again, forecasting can be for different use cases. I've talked about demand for CPG. Similar use case could be for airline, where they want to understand how many seats will be sold for the morning 8 a.m. flight from Delhi to Mumbai. So these are scenarios, these are future scenarios you're building based upon the past sales that you have done for that particular flight segment. So just to quickly give you an example. Sorry, I have a very scratchy throat suddenly. Yeah, Himanshu. Yeah,
Thank you. Ma'am, we have our one attendee, Devansh, who actually wants to talk to you. So if you give the permission, can I allow him to talk?
yeah, please go ahead. Yeah.
Okay. So Devansh, okay. Devansh, now you're on live. I mean, you can speak up and put up your questions.
मैम आई हैविंग क्वेरी दैट कि हम आर्टिफिशियल इंटेलिजेंस के साथ डेटा साइंस में मतलब क्या रहता है मैं क्या फर्स्ट टाइम अब वी आर पास 12th दैट टाइम
Okay, so Devansh, just to quickly go back to the program structure that I talked about. See, for you to specialize in AI, you need to know the fundamentals of AI, and which is where the data science course, जो हम अभी आपको, we have shown it on the, I showed a PDF that is comprehensively covering. आपको fundamentals पूरे सिखा देंगे हम. Let me quickly project it again. Excuse me. So you will get a foundational knowledge understanding in the mathematics and statistical streams of data science. You'll also understand how to do coding, which is very essential for you as a data scientist, because you are ultimately creating a repeatable structure or a program that you can automate eventually. So you will need to understand to code on certain platforms like Python, PySpark, R, and all. That will be covered comprehensively. And then we are also providing you the solution in machine learning and big data analytics. So it is paving the way for AI, and eventually you can take specializations further in that. Anju, very quickly, are we also giving some conceptual understanding on AI and all, which I may not have covered here in the program?
So we do have some courses in higher semesters, 6th semester and 7th semesters, where we are covering deep learning and some advanced concepts of AI, some advanced courses in AI. So yes,
Yeah.
we do have these courses in 6th semester and 7th semester.
Okay. Sure, Devansh. So go through this PDF. I'm sure Himanshi will be circulating it to the attendees. So you will get a good understanding of हम आपको fundamentals क्या सिखा रहे हैं, advanced क्या सिखा रहे हैं. And you can also go through the program brochure, which will be available to you. So that'll have all the details. Yeah. Okay. Okay, Himanshi, any other question here?
Yeah, okay. So Devansh, just want to ask if you have any other query, you can ask it. Or are your queries done? Okay, so I think, ma'am, we're done with the queries.
Okay.
Okay, this last question is from Priyanshu, and it says, I think Anju ma'am is also answering the question. Is data science first step towards the, okay. So this question was, is data science first step for machine learning?
See, machine learning is a concept which has been arrived from the world of data science only. So, okay, so think of it like this, that I always tell people to imagine it like this. For you to drive a racing car, you need to first put it in gear 1, right? Then you put it to gear 2, gear 3, gear 4, gear 5. That's how your car will, pick up the speed. So think of it as sequentially important, while they're interdisciplinary, and machine learning and deep learning and AI are kind of part of the universal world of this, but the program that we are offering to you is going to set you to an advanced track in data science world, right? Then you can build your super specialization that, okay, I want to be an analyst or I want to be a data scientist. That's your choice, like you want to be a machine learning engineer, you want to specialize in deep learning, for example. But without having the fundamental knowledge, you will not be able to successfully compete with people who have that knowledge. Again, a very quick example for that is if you want to really learn a language like French or Italian, or you have to learn the basics. While you can learn and grasp the phrases, you may buy a book which says 1000 Italian phrases and you learn those phrases by rote. But if you start conversing with an Italian, a true Italian, you will not be able to hold a conversation because आपने fundamentals नहीं सीखे हैं. So the key difference that we have in this program is right from the fundamental knowledge to advanced. आपको comprehensively 4 पूरे साल मिल रहे हैं to build your career, and side by side you are getting the opportunity of working on hackathons, on datathons, on competition. आपको एक mentor भी assign हो रहा है. You get options of internship. तो आप अपना ट्रैक इन दीज 4 years ही बना लोगे. आपको अलग से कुछ सर्टिफिकेशन नहीं लेनी पड़ेगी from Udemy or White Hat or all the companies that are floating in the market today. आप comprehensively यूनिवर्सिटी के साथ ही आप कर लोगे. आपको अलग से इन्वेस्ट नहीं करना पड़ेगा in your certificates.
Definitely, ma'am, and I agree with that. And I think I think we're done with the questions now. At last, I would just want to ask final time. If you have any query, attendees, you can post in Q&A box or chat box. If not, then I think I would take permission from Suchita ma'am now and Anju ma'am and Amritpal sir to wrap this webinar up. If you do not want to add anything to the webinar.
Yeah, I think they can reach out to Anju or to you to know more about the program. Visit Transorg's website, also visit LPU's website. So there's some interesting work we have also done. So we are always open to conversations with the students. But thank you for having us. Thank you so much. Looking forward to interacting with all of them. Thank you.
Thank you so much, ma'am. So I think Amritpal sir, if you want to add anything.
Excuse me.
Thank you, ma'am. Everything has been already been stated here.
Yeah. Okay then, sir. Thank you, sir. Thank you so much, ma'am, for coming in, for giving your time again, experience, and all our attendees are also saying thanks to you.
Thank you. And sorry for the cough and all. Suddenly got triggered while speaking.
Yeah.
But we are available online. They can visit our LinkedIn page of Transorg. They can connect with Anju and team. We have, they can always ask all the queries that they have for the program. But thank you once again. Thank you.
Thank you, ma'am. So with this, I think I take the leave from, of course, all the participants and our experts here. So again, at last, thank you so much for coming in. So until next webinar, stay safe and stay healthy. And
Thank you.
the next webinar. Thank you, ma'am.
Bye.
Bye, ma'am.